Hello and welcome back to Metacode. So today we are doing part 2 of the AP Computer Science free response questions series, I guess. It's only 2 videos, and we did questions 1 and 2, and today we're going to do the final 2 questions, questions 3 and 4. So question 3 is split up into 2 parts, and so is question 4, 3A, 3B, 4A, and 4B. And so without any further ado, let's get right on into the video. And if you want to check out part 1, it is in the description. So question 3 reads, many encoded strings contain delimiters. A delimiter is a non-empty string that acts as a boundary between different parts of a larger string. The delimiters involved in this question occur in pairs that must be balanced, with each pair having an open delimiter and a closed delimiter. There will only be one type of delimiter for each string. The following are examples of delimiters. So here, example 1 is like parentheses in your math equations, where you can't have 3 open parentheses and 2 closed parentheses. Just like in Java, you can't have more open brackets or open parentheses than you have closed parentheses. It's going to return an error. In HTML, you have tags. Those are like delimiters because you have one open tag and one closed tag. Some don't have closed tags, some tags, but that's not the point. Alright, so anyway, let's go down to the problem. In this question, you will write 2 methods in the delimiters class. So 3a will be one method, and question 3b will be another method. So we see here we have 2 things called open del and closed del, the open delimiter and the closed delimiter. So our first method is a helper method, which I think is just assigning the open delimiter and the closed delimiter. And so to be implemented in part A, which will return an array list of delimiters from the array tokens as described in part A. So let's go down to part A and answer the question. Here, a string containing text and possibly delimiters has been split into tokens and stored in an array of strings called tokens. Each token is neither an open delimiter, a closed delimiter, or a substring that doesn't matter. You will write the method getDelimitersList, which returns an array list containing all the open and closed delimiters found in tokens in their original order. So the following shows the contents of an array list returned by getDelimitersList for open and closed delimiters and different tokens arrays. So this is basically, we have our open del of parentheses, open parenthesis, our closed del could be closed parentheses, and this is tokens here. We have an open parenthesis, x plus y, closed parenthesis, star 5. And our array list, or our method, will return this. Our array list with just this and then this. And in example 2 here, our open parenthesis is an open Q tag, our closed delimiter is a closed Q tag, and this is our tokens, and this will return open Q, closed Q, because we have open, closed, and then we have another close. Anyway, so let's write our method. Now, if you're wondering why I'm not spending more time, it's because, on the test you'll have an hour 30 minutes to do 4 questions, which is a long time, and that's because they know it's going to take a long time for you to come up with what you have to do. This I kind of already know what I have to do because it's a tutorial, and I don't want to waste your time going through the thought process. So I'm just going to show you what my thought process was. And so let's just get on into it. So we know that we have to return an array list of strings, and we need to take in our string array of tokens, and that's already been done for us here with taking in the array list and taking in our string of tokens and returning an array list of strings. So we know that our goal here for this method is to create an array list with all of the delimiters in it. So let's create our new array list. And we need it to be of strings, obviously. So array list, and then in angle brackets, string. And then we can name this D equals new array list. And that should be good. Yeah. let's put string. We have to put string, and that should be good. Okay, so next thing we are going to do is we are going to create a for each loop. And if you don't know what a for each loop is, it looks through each part of an array and it will do something or not do something. And this can only be used on arrays. So you can do this with a for loop by looping through list.length. So we could do like for int I equals 0, and then I is less than, or whatever, our tokens.length. And that is definitely a way to do it. And then I plus plus. But then it would make it a little harder. While inside the for loop we would keep doing token bracket I to do this. And luckily for us, Java has it so we can do for, and then in here we do something here, which I'll just represent by dashes, colon, something else. And so this is for each, and then on the left side, string, str, we can say, and then the name of our array, tokens. So this is for each string in tokens. So for each string that is in our array list called tokens. And what do we want to do? So we want to check, is it an open delimiter or a closed delimiter? If yes, then add it to our array list. If not, that's it. So if str, which is the thing that we're checking for, if we can do if str dot equals, because we know that we can't do equals equals. For strings we do dot equals, and then in parentheses, I think I have one too many. Oh, never mind. If str dot equals opendel, which is the variable that was mentioned up at the top for opendel, or which is double bars, or str dot equals closedel, then we need to just add this element to our array list. So, sorry, by the way, I'm not using a code editor for this. I'm using a PDF editor, so that's why it's not like tabbing well or anything. And you will have to take this exam on paper, which makes it really annoying to write out the code by hand, but it is what it is. And so we just have to add it. So as we know, to add stuff to an array list, we just do name of the array list, which we named it D up here, d.add, and then our str. And that should be it. At the end of our for loop, we just have to return our array list because this method returns an array list. So return D. And that's it. And by the way, if you have an array of ints and we want to do a for each loop, then you could change it to int str. But in this case, we have an array list of strings, so we did string str. And it doesn't have to be named str, it can be named whatever you want. Okay, so that's it. If you do this, everything in here, you will get a 5 out of 5 or 4 out of 4, whatever this 3a is worth. But this will get you a perfect score for this question. Now on to part B of question 3. Write the method isBalanced, which returns true when the delimiters are balanced and returns false otherwise. The delimiters are balanced when both of the following conditions are satisfied. When traversing the array list from the first element to the last element, there is no point in which there are more closed delimiters than open delimiters at or before that point. The total number of open delimiters is equal to the total number of closed delimiters. So here it gives us an example. Consider a delimiters object for which opendel is tag sup and closedel is backslash sup, or slash, sorry, not backslash, sup. The examples show different array list objects that could be returned by calls to get delimiters list, and the value would be returned by a call to isBalanced. The following array list shows an array list for which is balanced returns true. And remember, all we have to do is just check, are these two conditions not met? Then we keep going. But if any of these conditions gets violated, then we have to say no. And whenever there's conditions in a problem, whenever they say the word condition, you have to immediately think if statement. And since we're checking each element, we also have to think either for each loop or for loop. And so it's already pretty easy for us to check, to figure out what we have to do. We have to go through tokens, again, like we did in the last problem, and check for the first condition. If it's violated, then stop everything. If not, check for the second condition. If that's violated, stop. And if not, carry on to the next thing. And if we reach the end, then we return is balanced as true. If we have to stop in the middle, then is balanced is false. So let's look at some more examples. This is the array list for which is balanced is false. And that's obviously because here we reach two closed where there's only one open. So even though there's an open one here, it's not balanced when we reach the third spot. So that returns false. And they have a few more here. I have a PDF for the test that I will put in the description below, so you should probably take that first before you do this video. And I already spoiled 3A for you, so I'm sorry about that. Anyway, so next thing that we have to do is let's create two variables. One to represent the number of open delimiters and one for the closed delimiters, because we obviously need that. So how about num open dels equals 0, and then int num close dels equals 0. And so next thing we're going to do, like I said, we have to go through tokens like we did in the last problem, and then we just have to check for the two conditions. So now let's do for each. Let's do another for each loop, which is the easiest way to do it. And since we have another array list of strings, we can do string. We can call it str, or let's just call it str again. For each string in our tokens, or sorry, array list of delimiters. I'm sorry for saying tokens this whole time. We're checking through delimiters. For each string in delimiters. And this is an array list, but we can still do for each loops on array lists. For each string in delimiters, then we are going to check if str dot equals and then open del. So we're just checking if this is open del. Then add 1 to the amount of open dels. So we can just say num open dels plus plus, because we're adding 1 to open dels. Gosh, this PDF editor is kind of annoying. Num open dels plus plus, and then we can do if str dot equals close del, then let's just add 1 to close dels. Num close dels plus plus. Okay, so I just realized I kind of got to pick up the pace because this tutorial is getting kind of long. So let's just, now we have to check for our conditions. So first we have to check if num open dels is greater than, if num closed dels is greater than num open dels, then let us return false, because that is wrong. So return false. And so that's going to take care of our final condition. And let's look at our second condition. The total number of open delimiters is equal to the total number of closed delimiters. But this will only be checked at the end. So at the end, we can check if num open dels equals num close dels, then let's just say return true, because it's true, everything is equal, and it hasn't already been canceled by the earlier condition. So return true, and then we can just put an else here, because everything else will mean that it's not equal. So else return false, and that's it. That's literally everything. So if you do this, then you will also get full credit for this problem. And so that's that. So question 3 is in the bag. And now let's go on to the final question, question 4. So I'm going to talk a little bit faster because I don't want this tutorial to drag on forever. And by the way, you do have an hour 30 to take this test. I think I said that earlier. So don't worry if you're not coming up with the stuff as fast as I am right now. I think I already said that earlier. Anyway, number 4. The Lightboard class models a two-dimensional display of lights, where each light is either on or off as represented by a Boolean value. You will implement a constructor to initialize the display and a method to evaluate the light. And here we have our class Lightboard. A private Boolean and then a two-dimensional array of Booleans called lights. And the Booleans are either on or off. So this will just construct a Lightboard having num rows and num columns. And so what we have to do here is we just have to construct a Lightboard object in our question 1. So let's go down to, part A. Write the constructor Lightboard class. Write the constructor for the Lightboard class, which initializes lights so that each light is set on with a 40% probability. The notation lights and then RC represents the array element at row R and at column C. So basically, if we do lights and then bracket 1 and then bracket 2, then that basically means lights row 1 column 2. So you can think of it kind of exactly like an array. In your math class, maybe when you were learning multiplication, you went over arrays and like multiplication tables, kind of like that. So a complete Lightboard constructor below. So precondition num rows is greater than 0, num calls is greater than 0, and each light has a 40% probability of being set to on. So let's just hop right into it. So I believe they already have the constructor for us. Yes, they do. And so let's create our new Boolean array of lights. So lights equals Boolean, and then a 2D array. Now 2D arrays, I kind of not the biggest fan of 2D arrays, but we have R and C, as we remember earlier. And we let's do num rows and num calls, because this is just creating our Boolean array. So num rows, so we want our array to be as big as the number of rows and as big as the number of columns, because if we just do RC, then it would just be one small part of the array. So lights equals Boolean array with the total amount of rows and the total amount of columns, obviously. Now, the next thing we have to do is loop through the number of rows and the number of columns. Now, this is where a lot of people got thrown off on the exam. They only did one for loop, and they weren't sure what to put in their for loop. But we actually have to do 2 for loops. And so we can do we can do int r equals 0, and then r is less than, and then we want to say r is less than num rows, because r is representing the rows. So we have to loop through rows, r plus plus. And then inside of that, we also need to go through columns, because this is a 2D array. So for int c equals 0, I'll just do c, so that way you have a bit consistent. C is less than num calls, and C++. I don't like the language. C++. So what this is doing, if you're confused, is it's just looping through everything. It's looping through the number of rows, and then in every row it's going to loop through each column. And what we have to do now is just give it a 40% chance of each light turning on. So this is going through each light and creating a random chance of it being on or off with a 40% chance. So we can use math.random for this. So let's say double rand equals math.random. And this is how we create a random number, or just a random kind of chance thing. And then we can say lights RC, which is basically just our thing at R. So this is going to start at kind of like a coordinate system 0, 0, and then it's going to go to 0, 1, 0, 2, all the way till it reaches the end of the row, and then 1, 1, 1, 2, 1, 3, 1, 4, till it reaches the end of that row, and it's going to just go through the whole array. So we can do RC, which is going to get each current square that we're on before we move on to the next thing. So lights R and then C equals, we can just say rand is less than 0.4. And this is going to give it a 40% chance of it turning on. And that's it. If we do this, we will get question part A correct. And now it is time for the final problem. So who's excited? Because I know I'm kind of not really super excited. So part B reads, write the method evaluate light, which computes and returns the status of a light at a given row and column based on the following rules. So basically we're just going to go through each light and look at whether it's on or off, and look at here at these conditions. So if the light is on, return false if the number of lights in its column that are on are even, including the current light. So we go to a light, we look at its whole column, and we have to check if the whole row has a number of even on lights. And that's only if the current light is on. If the current light is off, then we have to return true if the number of lights in the column that are on are divisible by 3. Otherwise, return whether the light is on or off. Now I know this is really confusing, and this is kind of a tactic of the college boards when they're making these exams. They try and make it as confusing as possible, but it's really not as confusing as they kind of make it. As they make it seem, they make it seem a lot more confusing than it really is. I'm just saying the same thing over and over again. Okay. So for example, suppose that lightboard sim equals new lightboard 7.5 creates a new lightboard with the initial states shown below. So this is going to create a array with 7 rows and 5 columns, and here it has everything that's on or off. And so this is going to say like sim.evaluate light 0, 3. So we can go to 0 and then 3. And so this is going to be false because the light is on, but the number of lights that are on in its column is even. And it says here return false if the number of lights in the column are even and the current light is on. So let's just move on to the actual code. So let's create a variable to represent the number of on lights, and we can call this numOn. Int numOn, and we obviously need to start that at 0. And so now we can loop through lights. So the way we do this is for, we can say int r equals 0, r is less than lights dot length r plus plus. And inside this for loop, what we are going to have to do is we are going to check if each light is on or off. So if lights, and then we have our two parameters, row and call. So if lights row and call, and we don't have to put equals equals true, because as we remember, Java will automatically assume that it's true. So if lights row call, then we'll add 1 to num on. So num on plus plus. And so this is going to loop through everything. And so now let's do our if statements just to check for our, this is going to check for our conditions. So if lights row and then call, which is our spot that we chose for whenever we're calling this function, is true. So if this is on, and, so which is and, num on %2 equals 0, which is basically going to say if the light is on and there are an even amount, because the equals 0. And so this is basically checking, is the stuff in here when divided by 2, the amount of number of on lights is 0, then we're good. And the light also has to be on. So this is basically looping through everything in the column with the light on. And so this is going to say if lights row call and num on %2 equals 0. So this is checking, is there an even amount of lights on, and the light is on, then we have to return false, because that is what it said in the question. And then next thing we can do is if we can do lights row call, call, and then we can say equals equals false, because we need to check if it's off now, because the second thing is if it is off, then return true if the number of lights in the column is divisible by 3. So if it's off and this is divisible by 3, so if num on %3 equals 0. Oops, I just realized I took the parentheses off. Okay. Then let us return true. And then else, we are just going to return the status of the light, which is light row call. Oh, by the way, this needs to have an S here, because it's lights is the name of the array list. And lights row return. And that's that. That's literally the whole thing. So really a lot of people try and write too much code, but in reality this is the whole problem. And most of these questions here that we see, they're not a ton of code. This was only 6 lines or something. So there's not a ton of code that goes into it. It's just tough to come up with what you have to do. And so see, we reach the end of the exam. So that's it for today's video, and I will see you guys in the next one. If you guys didn't check out part 1, then you should, because it's cool. So I'll see you guys in the next one. Peace.